Okay, so we're looking at this very first one, using the rectangular models to expand each of the following products. So, on my very first, 3a parentheses 2a minus 5 equals, which one of those is going to be my height? Height. What?
3A.
Who said something?
3A.
3a, good job. All right, let's write 3a over here. And my width? Good, 2a and negative 5. All right, let's find the product of the first rectangle. So I'm going to take my height, 3a, multiply it by my width, which is 2a, for a
6A squared.
good, an area of 6a squared. Thank you. Looking at my second rectangle, I'm going to take my height of 3a, my width of
Negative 5.
-5,
Negative 15A.
-15a. All right, let's bring those up here. So I have 6a squared. I have a negative number, so minus 15a. Is that my final answer? Yeah, why is that my final answer? Because we don't have any like terms. Very good. All right, box that answer up. All right, moving on to my second one. Joey, what's my height? Good. 3 and negative 2, so plug those in. Negative 2 what? C. Thank you. And Imagine, what's my width? Good. 4C and negative 1. Very good. All right, let's start finding those areas of each of those rectangles. So for my first box that I outlined in black, what is going to be my height and my width, Kelsey?
3 times 4C.
Equals?
12C.
12C. Awesome. All right. My red rectangle. Beyonce, what am I going to take?
I don't know, I did mine backwards, but it's negative 2C times 4.
Times 4C. And that equals?
Negative 8C squared.
Negative 8C squared. It's all right that you did it backwards as long as you caught it, you know? All right. Up here, my longer red rectangle. My Rihanna. Height and my width, please.
3.
3 for my height and my width.
Negative 1.
-1 for an area of
Negative
-3.
3.
Thank you. And Brendan, for my purple rectangle, negative 2C times negative 1 equals positive 2C. Why is it positive 2? Because the negatives cancel out, right? Good job. All right. Remember, bless you, that you write it up here next to the equal sign, but I do not have a ton of room up there. So I'm going to write them down here. So I have 12C minus 8C squared minus 3 plus 2C. Final answer? No. Why not? I got to combine like terms. Which two terms am I going to combine, Deontay?
12 and the 2.
Good. 14C, right? So I'm going to have 14C. Oh, whoa, whoa, whoa. Hold on a second. I'm going to get excited. Yes, ma'am.
Oh, yeah, I have two questions.
Yes.
Ain't that supposed to be in order? Because negative 8, ain't that supposed to be in order?
Yep.
And I have another one.
Yes.
Ain't you supposed to have that A for area on the first one? Or no? Yeah, A equals.
A equals like in the box,
Yeah.
in the rectangle. You can put A equals, and we
No,
have
like for your final answer, it's supposed to be A equals and then the answer?
right here.
Yeah.
This one, because we already have this equal sign here, we know that we're finding the area, so you don't have to put that A. But you can, you definitely can, but you don't have to necessarily, okay? As well as in the box, I had been writing A equals, and you can definitely still write that, but you don't have to. All right, so good catch, Rihanna. Making sure that it's in exponential order from largest to smallest. So which one is going to go first?
Negative 8c squared. And then positive 12c. Wait, no. And it's positive 12c.
Yeah, but if we combine those like terms, what is it going to be?
14.
Okay, perfect.
And then negative 3.
And then -3. Very good. Nice catch. All right, does everybody have that for the front side? I'll let you get that down. All right. Okay, so for this last one, we're going to find the greatest common factor of the following terms. We have 600 m to the third n and 450 m to the second n to the second. All right, so these we did not cover in our notes yesterday, but we are going to learn about them today. So let's go ahead and start going over them together. And so maybe you'll get kind of an idea of what we're going to do today. All right, so find the greatest common factor of the following terms. Let's start with 600, m to the third n. So who can give me some factor pairs of 600? That's the easiest way. Remember, which is the easiest thing to start off with? 1 and 600. Very good. So I have 1 and 600. Next, I have, what's the next? Yes, Brendan. 2 and what? 20 and 30, okay. What else can go into 600? Can 2 go into 600? 25 and 24, all right.
Basically, the numbers at the bottom are just where to write the answer because you're factoring two different numbers here.
Okay.
You're factoring 600 and you're factoring 450.
Mm-hmm.
So next to 600 is where you'll write out them in prime factorization form.
Oh, okay. Gotcha. So then up here, do you
You're
write
gonna do the factor trees.
okay.
So the 600 is where you're going to factor tree it. The large 450 is where you're going to factor tree it.
Do you want
And
to?
then you're going to write your answers down below.
We haven't done the factor trees yet with them.
Oh, you haven't done the factor trees at all? Okay, that's fine.
They know how to. I
Then
mean,
just walk them through.
okay.
Yeah.
Okay.
Walk them through the factor trees.
Do you want me to
Or
still
the prime,
keep
the trees.
recording
Yeah,
this
you're-
one?
Yeah,
Okay.
keep recording it. Just say, we're going to scratch that.
Okay. Scratch that. Sorry, guys. Sorry.
That's my fault because I didn't realize, I thought you got past another point, so that's my miscommunication.
No, totally okay. Not a problem in the slightest. All right, so we are going to start off with our factor trees, which is where our notes are going to start today. So if I am taking 600, which two numbers would you guys like to do for our branches on our factor tree? 24 and 25. All right, I like it. 24, and, ooh, my bad, 25. All right, now what two numbers can go into 24? Which two numbers can I multiply together to get 24?
3 and 8. Yep.
3 and 8. Okay. Can I multiply anything together to get 3, or is 3 good?
3 is good.
3's good. All right. What about 8?
4 times 2,
2 and 4. All right. Is that good?
Yep. Wait, no.
Mm,
4
the
the
four.
4 2.
4. I have 2 and 2. All right. Okay. So what I'm going to do now is I'm going to go ahead and circle my prime numbers. So I have 3. I have 2. I have 2. And I have 2. Okay, let's go ahead and do 25 now. What can I multiply?
5 and 5.
5 and 5.
And that's prime number.
All right, those are prime numbers, so let's go ahead and circle those.
Now this is much easier.
This is much easier, isn't it? There's an
Question for you guys, and you weren't here first semester, so it's like you know this. What did we use this for?
The expo is when we used to have to multiply them all together.
Solving equations with,
Uh,
what's that thing called? That little.
I know what we're talking
Square roots, yes. When we had to simplify square roots and solving equations with square roots.
Yeah, that was so hard.
That's probably where this is familiar. We're like, oh wait, we have done this. We did it for
Good.
first semester.
That's awesome. I'm glad that you guys are
Why you say yeah?
familiar with it.
Yeah.
Okay, so now down here for the 600 equals, that's where we write these out at.
Yes.
Okay. Now yesterday we did not write these in numerical order from smallest to largest. Today I want you guys to make sure that when we write out these prime numbers, you are going to write them in numerical order. So we are going to do 2 times 2 times 2 times 3 times 5 times 5. And if you'll also notice up here, we have m to the third and n. So what I'm going to do with those is I am going to write them out as well because we're multiplying those by 600. So m, and I have one n, so n. Okay, now let's do the factor tree with 450 now.
45 times
I'm sorry, what, Haley?
450 times 100.
450 times 100 or what times 100? I don't think, can you divide 450 by 100?
Got a headache.
10.
45 and 10, right? Okay, awesome. All right, now what two numbers can I put into 45? What two numbers multiply to equal 45?
Minus 5 and 9. No, right. Right. Okay.
Good. 5 and 9. 5 is a prime number. 9 is not. However, what two numbers can I multiply to?
3.
3 and 3. Very good. Go ahead and circle those so we know what numbers we're working with. Let's go over to 10,
4 and 5.
2 and 5. Are those numbers done?
Yep.
All right. Thank you. Bring those down. So I have 2. I have 3. I have 3. I have 5. And I have 5.
Man, don't forget them 2 M's.
Oh, I have my 2 M's too. Thank you.
M's with M's.
I have 2 M's and 2 N's.
That's all we do for this?
Not yet.
Yeah, I figured.
We're not finished yet. All right. Make sure that these numbers all line up so they're nice and organized. So when we start to find the numbers that they have in common or the variables that they have in common, it's easy for us to just go 2, 2. All right. So let's look. Which two numbers do both of these have in common?
2, 3, 5.
They both have 2,
M,
3,
not everything.
5, 5. Remember, they both have to have the same amount. So 2 2s, 2 3s, 2 5s, 2 5s. All right, now let's look at the variables. Which variables do we have in common? They both have an, it looks like an M. Do they have another M in common?
Yeah.
Then they just got
What about that third M? No. N?
Yes.
Perfect. All right, we're almost there. We're so close.
You drop down, you're gonna put GC.
Oh.
Okay. Okay. Do you put the, should we like put it out first, like the 2 times 3 times 5 times M and then the GCF?
I
Or
went for the first time.
okay.
Find the GCF that times that equals the final answer.
Okay.
Just until we get good at writing it and understanding it.
Okay. Okay. All right. So for this one, let's write GCF equals. All of those numbers that we had in common, we're going to go ahead and write.
So 2 times
So
3 times 5
good.
M times 8.
Whoa, hold on. Do we have 2 M's or just one, or 2 5s or just 1 5?
Just like 1 5 because it is stand for the rest of them.
Mm-mm. If it has 2 pairs, then we're going to write all those 5s. So we have, sorry, that was confusing. So we have 2, 3, 5, and then we have another 5 in common. So we have to write that one too. 5. We have 2 M's in common. And then we have an N in common.
Once just combine those. M.
We're,
M, once just combine them.
we are, yeah, we are.
It's like 2 minutes.
Then one just combine them 5.
All right, so who can tell me what 2 times 3 times 5 times 5 is?
We gotta do that too.
To find the last bit.
150.
It's 150.
Then they say you got to do a factor tree on that number.
150. I have how many M's?
2.
So I'm going to put M to the second. And I have 1 N
Y'all just make math boring,
box. And that is your final answer.
See, I'm gonna do bad on this lesson.
No, you're not. Once we start going over it more and more and more.
This is all we're doing. Like, there's no finish to it. Like, this is just all.
Eventually we're going to get to the point where we have a larger amount of variables.
Oh.
So
When you